When the original IBM PC came out in 1981, it sounded something like this. Then a little Canadian company called AdLib came along in 1987, and PCs started to sound like this. When it comes to sound cards, one of the obvious options to consider for your 80s retro PC is of course the legendary AdLib. There is a small problem though. They rarely show up on eBay, and when they do, they are likely to be the most expensive part of your entire build. Last time I checked, there was one card on eBay, and the bidding went all the way up to $800. Today we are going to look at a better option. We are going to build one from scratch. Since I have the cursed Canon 286 PC on the bench, we'll use it to try out the card. Hopefully this will be the first video featuring this Canon where we don't blow something up. If we have some time left, we will also try out a few things that you guys have recommended to revive the hard drive. Okay, so first we're gonna need some PCBs. So PCBWay has this thing called the shared project page, and that's where I found these. So you can basically just browse around existing projects, and if you find something you like, you can just put it in the cart, make whatever changes you want, and then just place an order. And that's exactly what I did. So a while back I got a bunch of samples from PCBWay, and among those samples there were these PCBs. And I thought they look awesome, so I wanted to try a PCB out with this look. And I haven't actually opened the package yet, so I'm yet to see if they look this good. So let's take a look inside. They are pretty well packed, I have to say. So let's remove this plastic and see what they actually look like. Yeah, that looks awesome. As you can see, they are quite far from the original look. So then we're gonna need a bunch of parts, of course. And aside from two of the components, all parts are still available from your favorite electronics supplier. And there is even a cart available on the shared projects page. So you can just copy-paste it into your web browser, and you will have all the needed parts in your cart. Aside from these two buggers here, so these are the OPL2 chips, and they are available on eBay and AliExpress. And you're also gonna need a bunch of these. So these are YM3014B. And then we should be all set. So let's start soldering components. Okay, let's start with a bunch of resistors. And as you can see, I have ordered without a silk screen. And I know what would look really neat on this PCB. A large AdLib logo in gold on the side here. That would look fantastic. I wonder if that could be done. I guess it would require some more copper underneath the solder mask, and then a cutout in the solder mask that looks like the original logo. I guess that should be possible. Yeah, if you're good at redesigning PCBs, feel free to make a version with the large golden AdLib logo and send the files my way. I'd love to have such a card. Okay, let's get some caps on that board. And you can easily find instructions online. And if you order the PCB with the silk screen, you don't really need an instruction, because all the values are printed on the PCB. And I'm using another card here to see which component goes where. And even if you're lucky enough to have one of these original cards, I seriously doubt that you only have one vintage PC. So instead of swapping that card in and out of different systems, you can just order a bunch of these And you can keep that original nice card on display. And that was the last ceramic. And if you're not into soldering stuff, you can easily find a bunch of these pre-made on eBay. Not with this black look, of course. Okay, that was the last ceramic cap, and the rest is tantalum caps. And they are polarity sensitive, so pay attention when you put these in. Otherwise you're gonna get a light show, and it will fill your lab with smoke. Yeah, if I got things right. This project started off by Sergey making an AdLib compatible card. And then Tube Time redesigned the board to make it look like the original AdLib. And that was the last tantalum. And then we have the only electrolytic cap on this board. Next we're gonna add some sockets. And these cards didn't have sockets originally. But we're not going for the original look today. So I'm gonna put all the chips in sockets. And I just received a large batch of sockets that I ordered because I ran out of sockets when we tried to repair Adrian Black's board. So now we can finish that project. Next we have the only transistor on this board. And the only diode on this board down here. And next up we have this unnecessarily fancy Bourne's pots. And I say unnecessarily because they are pretty damn expensive. We're not really going for the original look anyways. So it would have been better with just a regular pot. For this project at least. And as I mentioned, we are going to try out this card in the cursed Canon. But eventually I think this card is gonna end up in my 5160. And if that Canon starts behaving and stops burning things up, it will eventually get to play with the Roland MT32. And the last part that we need to solder is the audio jack. And it's a snap-in. But these legs are slightly bent in. So let's bend them out. Perfect. And speaking of Tube Time, I actually have one of his other projects in that box from PCBWay. But I haven't ordered the parts yet. So that video is probably a few weeks away. And then we've got two 74 LS138s. And one LS245. And then we've got one 74 LS04. Next we have an op-amp up here. And then we have an LM386 up in this socket here. And finally we have the two obsolete parts. So here we have the Yamaha 3014. And of course the famous OPL2 chip. The Yamaha YM3812. And we're sort of done. So we are gonna need a bracket as well. And you can 3D print them. Or you can do like I do. I bought some plain brackets from Mouser. And I'm gonna drill the holes myself. And here's our finished sound card. And we definitely need to sort out that golden logo. That would make it really pop. So before we continue and try it out, I need to fix this board. So if you haven't watched the previous videos, we have this MiniScribe drive. And it blew out its magic smoke without leaving any traces. So we don't have any burn marks, and I can't find any holes in any of the components. So far we have checked all the caps for dead shorts. We have checked the values on the electrolytic caps and the tantalums, and we replaced one of them because it was dead. We have tested all the diodes and the transistors, and everything seems fine. So I'm gonna just quickly resolder back all these caps, because apparently I was in a hurry leaving this project. And then we're going to test the debug command from DOS. So I'm going to resolder those components off camera and we'll move on to the tests. And if you want to watch the previous videos in this mini-series, you will find the links down below in the description. Okay, so the hard drive is put back together. Let's install the controller and some cables for the hard drive. And since we blew out the magic smoke from my 5154 in the previous video, I'm gonna turn all the switches off for the graphics and install a VGA card. This is the Trident TVGA 8900CL. And for this test I have removed the 5¼ inch drive. And we're gonna borrow the drive from the 5162 project. This flat flex only has connectors for card edge connectors. But luckily I have this thingy here. It's an adapter from a card edge connector to the usual diskette drive connector. And I actually found this on the floor at Computer Reset. I think it was in the repair room. And here it is, put into use. I hope it brings some luck to this project. This power supply only has large Molex connectors, so we're gonna need an adapter. I guess we'll start with a quick test. And the hard drive still spins up, but it still doesn't boot. And it seems to be pretty happy with that VGA card. And we're up and running with DOS 622. Okay, let's try this. G equals C800:5. And nothing is happening, unfortunately. And I think the entire system hanged. Okay, I checked the dip switches and they were not correctly set. So let's try again. No, still nothing. I guess that suggests that there's something wrong with the controller. Okay, so I actually found a manual online for that controller. And it's a VD1003 VAH. And according to this manual, use of the IBM Advanced Diagnostic or similar program for IBM compatibles is necessary since these controllers contain no onboard basic input-output system BIOS ROM. So I guess it's not made to be used with a debug command. Well, that's some pretty graphics for DOS. Okay, so I decided to try OnTrack Disk Manager version 9.57. And I'm getting this error here. Disk Manager has detected an incompatible CMOS geometry for this drive. To correct this problem, enter your CMOS setup and perform one of the following. Problem is that we can't do that because we don't have a CMOS setup. And I have tried to low-level format, but I just keep getting errors. So this doesn't seem to work either. And Disk Manager seems to think that it's an 8.4 gig drive. Okay, let's try SpeedStore next. And this is version 6.5. And the system recognizes one drive. And machine ID IBM AT. So far so good. Let's try diagnostics. Controller unsupported type 255. And we're getting internal controller test passed. So that's weird if it's unsupported. Let's try manual setup and initialize. Or perhaps type. Let's try type. Select or change drive specifications. That's exactly what we want to do. Okay, that's interesting. So we can choose between different manufacturers of hard drives. And MiniScribe is on the list. And the drive we've got is an 8425. 8425, and it's on the list. So here we have all the settings for cylinders, heads, sectors, and so forth. That's a pretty fancy software so far. And then we've got defect manager, and I'm not sure if I need to re-enter the defects. The drive has a few defects, but I'm not sure if I need to re-enter that information. So let's just go to initialize. We can always go back and try again. Okay, standard, initialize the entire drive. let's try that. Function will destroy data. Yeah, we don't have a choice, have we? Well, maybe we should. We are prompted for defect locations. I guess we better enter that data. Okay, so that should do the trick. Scan media surface to locate locked or defective areas. Yeah, we should definitely do that. And initialize. And I was a bit trigger happy, so I had to go back and change to the MiniScribe 8425. So now it's checking the correct hard drive. This is gonna take a while, so I'll skip ahead here. And I don't know about you, but I'd say this is a progress, because at least now it's doing something. Yeah, it's definitely reading from the hard drive, or at least trying. Okay, and I got an error, so apparently I had to erase the defect list before I could run the scan. But now it's up and running again. Well, unfortunately we got defect table overflow again. And that list of defects is very long. This is page 4. So it doesn't seem to be able to read the defects. I guess I'll try to enter the defects manually and then try to low-level format. Okay, fingers crossed. Here goes nothing. And we've got an error again. Controller fails to respond. So this isn't working either. Crap. Okay, so next up we're gonna try the 5170G setup. Let's see if this works. Your CMOS RAM has lost power. And that is correct, we have removed that battery. Let's continue anyways. Okay, let's go for this hard disk option here. Okay, so we get to choose between a bunch of hard drives. Let's see if there is a manual mode. Okay, so how do I enter the values? Well, I only seem to be able to choose between 47 different types, but I can't see how I could enter the values. Well, this is almost spot on, so let's try with this first, and we'll figure out later how to enter the values manually. Okay, let's try to reboot and see what it does. Yeah, now we're getting a memory size error, so the software seems to work, because we never entered how much RAM we had. Press F1 key to continue or Ctrl-Alt-Escape for setup. Is this the original BIOS? Hey, maybe we're lucky here. Hey, I think this is the original Canon BIOS setup. Are we finally getting a break here? Well, let's try to change the fixed disk. Well, we get to choose the hard drive type from 1 to 47. But I have no clue what number this drive is. So let's just try with something. Let's go with 47. Well, at least now we know how to enter the setup for this machine. So that's a bit of a breakthrough for this project actually. I'm just gonna pick random stuff here. We don't get to choose that high density 3.5-inch diskette drive. So let's just go with option 2, which is the original drive. And for graphics we're gonna go with special adapter. And I wasn't paying attention to how much RAM we've got. I guess I could check the video and see if the camera caught it. Okay, let's try this and see what it does. Okay, we've got 1 meg. I guess we could correct that memory error now. Or perhaps we shouldn't. No, let's not, because this is our way into the setup. And until we know how to enter the setup without an error, we're gonna leave it like this. Okay, so I'm back in the setup utility because it wouldn't boot from the diskette drive. So let's try to change it to the 720K. And I think I'm gonna start our tests with the hard drive with option 1. Well, I guess we need to low-level format first somehow. Okay, so I'm back in G setup, and here I'm gonna go to hard disk and change to type 2 because it has as many cylinders and heads as our MiniScribe drive. So this might work if we're lucky. Well, I don't think we can low-level format with this app. And I ran into the next problem, because the original BIOS doesn't have the option for the high-density 3.5-inch diskette. So I'm back at G setup, and here we have that option. Okay, so now we should be able to run on-track disk manager from our high-density 3.5-inch diskette. And it worked. Excellent. And we've got the correct information now, so we don't have that 8 gig drive anymore. We're now down to 21.37 meg, and that is probably correct. Well, we still need to low-level format, so we're back at speed store. So let's try to initialize the drive. And our defects are gone, of course, so let's add them again. Okay, here goes. Oh crap, no, we still got an error. So either this software isn't compatible with this controller, or something is still broken. Well, I'm running out of time for this week, so we better press on and test our new sound card. And I'm gonna keep the 3.5-inch diskette drive in the system until we have fixed it. But I will replace it with the original drive, because that 1.2 drive is a perfect match for a 286. And the VGA card gets to stay too, until we have fixed that EGA display. Okay, let's see if that sound card works. And now we get to choose AdLib. And it works! So finally some luck with this project. And I'm recording the sound directly from the sound card. So what you hear now is the sound coming out of that black AdLib. And it sounds pretty damn good to me. Well, I guess we did some progress with this project today. We now have period correct sound, and we know how to access the BIOS settings. Next I'm going to order some more parts for the PCB on that hard drive, and I will try to bring something out of storage with a working MFM drive and controller. That way we could test the controller and the card separately and find out where the fault actually is. I will also make an IBM 5170 setup disk that we could use to try to low-level format the drive. A big thanks to PCBWay for that black card, and to everyone who commented on things to try out in a previous video. If you have any more thoughts on this cursed Canon, let me know. Now don't forget to watch part 1 and 2 if you haven't already. There will be links below. Thank you for watching. If you want to support this channel, like, subscribe, leave a comment, and remember to ring that bell below.